For years, millions of people around the world have experienced something strange, memories that don't match recorded history. Did Nelson Mandela die in the 1980s or 2013? Was it Curious George with or without a tail? And why do so many people distinctly remember the Statue of Liberty being on Ellis Island, when in reality it has always been on Liberty Island? These bizarre discrepancies, known as the Mandela Effect, have puzzled psychologists for years. But now the most advanced quantum processors on the planet have analyzed this mystery, and what they uncovered is raising serious questions about the very nature of our existence. Could these memory shifts be more than just glitches in human recall? Could they be proof that our consciousness is shifting between different realities? Stay with us as we uncover the truth, and don't forget to subscribe for more groundbreaking discoveries. The idea that reality might not be as fixed as we believe is not just science fiction. It has been explored by some of the world's leading physicists, including Dr. Michio Kaku, a renowned theoretical physicist. Kaku has often discussed how quantum mechanics may play a role in shaping our perception of reality, suggesting that what we experience as the real world may actually be the result of deeper quantum processes. One of the most intriguing concepts in quantum physics is wave function collapse. This principle suggests that until something is observed, it exists in multiple possible states simultaneously. This means that reality itself is fluid, only stabilizing into one version when we collectively observe it. Some researchers propose that certain individuals may retain memories from alternate versions of reality before they collapse into a single timeline, which would explain why the Mandela Effect affects groups of people in the same way. Another theory suggests that parallel realities could be briefly overlapping, creating inconsistencies in memory and historical records. According to the many worlds interpretation of quantum mechanics, every possible outcome of an event spawns a new branch of reality. If these realities sometimes leak into each other, could it explain why large numbers of people suddenly recall different versions of the past? Adding to the mystery, AI-driven memory studies are now being used to analyze these shared distortions. Quantum AI is capable of processing massive amounts of data, looking for patterns in how memory inconsistencies arise. Recent studies using machine learning have revealed that certain Mandela Effect cases follow distinct, non-random trends, often linked to technological and cultural shifts. As quantum computers delve deeper into the nature of existence, their findings suggest that reality itself may not be as solid as we think. If true, this changes everything. But first, let's quickly look into the Mandela Effect. The Mandela Effect is one of the most puzzling psychological phenomena ever recorded. It describes instances where large groups of people recall events, names, or historical facts differently from how they appear today. These aren't just small mix-ups. Entire communities remember things wrong in the exact same way. Some of the most famous examples include Curious George's tail. Many people swear they remember Curious George swinging from trees using his tail, yet in every official book and TV adaptation, he has never had a tail. The Statue of Liberty's location. A significant number of people insist they remember the Statue of Liberty being on Ellis Island, but history tells us it's always been on Liberty Island. The Monopoly Man's monocle. If you remember the Monopoly mascot wearing a monocle, you're not alone, yet official designs show he never had one. Psychologists often explain this phenomenon as a result of false memories, our brains misremembering details due to suggestion, cognitive biases, or the way information is stored and recalled. But what if there's more to it? The quantum connection. Now, scientists are taking a groundbreaking new approach to all of this. Instead of viewing the Mandela Effect as just a quirk of human memory, they've turned to the most powerful computing technology ever created: quantum computers. Unlike classical computers, which process information in binary, zeros and ones, quantum computers use qubits, which can exist in multiple states at once due to a principle called superposition. This allows them to process vast amounts of data and recognize patterns that traditional systems could never detect. Using this technology, researchers fed massive datasets containing reports of the Mandela Effect into quantum AI models. The goal? To determine whether these memory distortions follow specific patterns, or if they could be evidence of something even more profound. Is reality shifting? As scientists analyzed the data, they uncovered shocking trends. Reports of Mandela Effect cases weren't random. They clustered around certain time periods, particularly the late 1990s and early 2010s, eras defined by rapid digital transformation. This raised the question, could shifts in our perception of reality be linked to quantum mechanics? Three leading theories have emerged: mass memory distortion, our shift from analog to digital media, like VHS to streaming, printed books to ebooks, may have subtly altered records, changing how we remember things. Quantum wave function collapse. Some physicists propose that reality exists in multiple potential states until it is observed, meaning our collective consciousness might be collapsing one version of reality into another. Parallel reality shifts. Quantum mechanics suggests that particles can exist in multiple states at once. Could our reality function the same way, with different versions coexisting until an event forces one to become dominant? If so, some people may retain fragmented memories from an alternate timeline. And here's where it gets even weirder. One theory we believe scientists should seriously investigate is the possibility that the CERN experiments were so powerful that they disturbed electromagnetic fields in the collective consciousness of millions of people. If true, this could explain why these memory anomalies have become more frequent in recent years. While these ideas remain controversial, one thing is certain: the Mandela Effect is more than just a simple trick of the mind. As quantum AI continues to explore the mysteries of memory, perception, and time itself, we may be on the verge of uncovering something far bigger than we ever imagined. The role of memory and collective consciousness. Memory, at its core, is not a perfect recording, it's a reconstruction. According to Dr. Elizabeth Loftus, a cognitive psychologist specializing in false memories, our memories are constructive. They take bits and pieces of experience and rebuild them, often filling in gaps with assumptions and external influences. But what if these reconstructions are influenced by something larger than just individual psychology? The idea of collective consciousness proposed by Carl Jung suggests that human minds are subtly interconnected. If so, could external forces, such as massive scientific experiments, shifts in technology, or even quantum entanglement, influence the way we experience memory? If the Mandela Effect is just a memory glitch, why do large groups of people experience the same false memories? Quantum mechanics and collective consciousness might hold the key, the simulation theory connection. A striking parallel to the Mandela Effect is found in simulation theory, which suggests that reality is not as solid as we think. Dr. Nick Bostrom, a philosopher at Oxford University, proposed in his famous 2003 paper that our universe could be a computer simulation created by an advanced civilization. Even Elon Musk has weighed in, stating, "There is a 1 in billions chance that we are in base reality." If our reality is simulated or partially generated in real time, glitches like the Mandela Effect could be errors in the system, small inconsistencies that hint at a greater underlying framework. Could quantum computers eventually detect if our world is coded rather than truly physical? The CIA, MKU, LTRA, and memory manipulation. The Mandela Effect also raises conspiratorial but intriguing questions. Could certain forces be intentionally altering collective memory? Consider Project MK Ultra, a top-secret CIA program from the 1950s to 1970s, which conducted extensive mind control experiments. Documents declassified in the 2000s revealed that the program tested techniques for manipulating memory, altering perceptions, and inducing false recollections. Additionally, Operation Mockingbird, another alleged CIA operation, was designed to influence mass media and public perception. If governments and intelligence agencies have actively experimented with manipulating memory in the past, what could be possible today with AI and quantum computing? Could a modern equivalent of these experiments be unknowingly influencing how we perceive reality? While speculative, it's undeniable that memory, perception, and belief can be subtly shaped by external forces. This brings us to quantum entanglement and human consciousness. Einstein called it spooky action at a distance, but could quantum entanglement influence not just particles, but human minds? In 2017, a study at the University of California, Santa Barbara suggested that human neurons exhibit quantum-like behavior, potentially linking consciousness to quantum mechanics. If true, it could mean that human thoughts, or even memories, are connected in ways we don't yet understand. Could the Mandela Effect be evidence that information is subtly shifting across entangled minds or even parallel realities? If reality itself is influenced by quantum mechanics, then our collective memories might not just be coincidences, they could be quantum imprints of alternate timelines. And then there's the CERN factor, a theory that deserves serious investigation. Some believe that high-energy particle collisions at the Large Hadron Collider, LHC, may have caused subtle disturbances in Earth's electromagnetic fields, potentially influencing collective human consciousness. Could the unprecedented power of these experiments have inadvertently altered the way our brains perceive time and memory? While speculative, the timing of Mandela Effect cases surging in recent years coincides with some of CERN's most significant experiments. Delving deeper into the provocative theory concerning CERN's experiments, we uncover a fascinating intersection of physics, consciousness, and reality. The Large Hadron Collider, LHC, at CERN, the world's largest and most powerful particle collider, was designed to recreate the conditions just after the Big Bang by colliding particles at high energy. These experiments aim to answer fundamental questions about our universe, but could they also have unintended consequences affecting human consciousness, the science of high-energy particle collisions? At the heart of this theory lies the concept of electromagnetic fields, EMFs, and their influence on the human brain. The human brain operates with its own bioelectromagnetic field, which is essential for neuron communication through electric impulses. High-energy particle collisions at the LHC generate immense magnetic fields, momentarily stronger than those of Earth itself. The suggestion is that such powerful fields could interact with the Earth's magnetic field, creating fluctuations that might subtly influence the human brain's electromagnetic activity. Electromagnetic influence on consciousness. Research has shown that the human brain is sensitive to external magnetic fields. Transcranial magnetic stimulation, or TMS, a technique used by neurologists to treat depression, involves applying strong magnetic fields to the brain to influence neuron activity. Drawing a parallel, if the LHC can alter Earth's magnetic field, even temporarily, it's conceivable that these changes could impact our neural networks. Such disruptions could theoretically lead to altered perceptions or the disturbance of memory encoding and recall, manifesting as shared false memories or the Mandela Effect. Collective consciousness and quantum entanglement. Another layer of this theory involves the quantum realm, particularly the concept of entanglement, where particles become interconnected regardless of the distance separating them. If, at a quantum level, human consciousness can become entangled, as some interpretations of quantum mechanics suggest, then a disturbance caused by the LHC might ripple through these entangled states. This interconnectedness could explain how large groups of people simultaneously experience anomalies in memory and perception, historical and anecdotal evidence of shifts. There are anecdotal reports that spikes in Mandela Effect occurrences and public awareness of them align with major operational phases of the LHC. While these reports are not scientific proof, they fuel speculation and call for more rigorous empirical studies to explore any correlation between the timing of LHC experiments and widespread reports of the Mandela Effect. This intriguing hypothesis suggests an urgent need for interdisciplinary research involving physicists, neuroscientists, and psychologists. Such studies would aim to understand the potential impacts of high-energy physics experiments on human cognitive processes. Investigating whether minute changes in Earth's electromagnetic environment could indeed influence human consciousness would not only illuminate the Mandela Effect but also broaden our understanding of reality itself. As quantum computing advances, we may soon have the tools to test these mind-bending hypotheses. Could future AI systems and quantum computing uncover direct evidence that reality is shifting? If so, the Mandela Effect might not just be a memory glitch, it could be proof that we are experiencing something far more profound about the nature of existence itself. That's it for today's dive into the mysteries of quantum computing and the Mandela Effect. What do you think about the impact of advanced experiments on our reality? Drop your thoughts in the comments below. Don't forget to like and subscribe for more thought-provoking content. See you in the next video.